Let's start now with the Ergan. We'll introduce you the Jupyter Notebooks tutorial for beginner and advanced people.
Just like Fabrice said, I'm going to present you the exercises we have developed for Python and for Jupyter Notebooks. The first thing to do if you want to access these exercises is to access the Jupyter Hub, and you can find the link to the Jupyter Hub from the Padlet. Here you have a Jupyter Hub access. And when you click on this link, you will be required to enter your Copernicus Marine Service credentials, and then you will reach the Jupyter Hub. So this is how the Jupyter Hub looks like. So this is my workspace, but you have a public folder which is entitled Shared Notebooks. Maybe you want me to zoom more. I don't know if you see better now. So
yes, it's better. Yeah, thank you.
You have a directory entitled Shared Notebooks, in which you can find all the training material which have been developed for the previous workshops. So you have the 3 workshops we've had this year, so the Arctic, the Baltic, and the Mediterranean that we're having today. You also have the regional training that we made in 2020, again for the same regions. And we have the trainings for the global oceans, so Africa, America, and Asia. So obviously, the training we're interested in today is the training Med 2022. And you can see that we have developed 2 exercises, one dedicated to beginners and one for intermediate level users. In this public folder, Shared Notebooks, you do not have the rights to write in this folder. I do not have these rights either. So the first thing to do is to copy this folder into your work directory, to your own workspace. And to do so, you have to open a terminal here. And then you write the following command line, copy the directory. It's in Shared Notebooks. It's called Training Med 2022. Then you add the dots, and the directory will be downloaded into your workspace. So here is mine. As I said, we have 2 notebooks, the one for beginners, the one for intermediate level. And so today I'm going to present you the whole notebook that is dedicated to beginners. The notebook which was developed for advanced user has already been recorded in a video, and it's available on YouTube, and you can find the link to this video on the Padlet. So it's already available. So today I'm going to present you, I'm going to present you the exercise for the beginners. If you're not familiar with Jupyter Notebook, this is how a notebook looks like. You have figures, you have text, and you have code cells. So these are Python code cells. And if you want to run a code cell, you can either click on the arrow on the top menu here, or you can use the keyboard shortcut Shift and Enter. And also, if the notebook stops working, you can try to restart it by clicking on the loop arrow on the top as well. So let's have a look at the agenda of this session, of this first exercise. So now we're having a quick introduction. Then I'm going to present you the data that we are going to use. Then I will show you how to access this data, how to download them. So several options for you to download the data from the Copernicus Marine Service. We will learn how to explore the product with Python. And then we will learn to make basic plots, basic figures, so maps, time series, etc. With the example of the sea chlorophyll concentration in the Mediterranean Sea. So that's it for the program of the exercise for the beginners. Before I start, I suggest you do not do the exercise in the same time as I do, because this video is being recorded, and within a few days it will be available on YouTube, and you will find the link on the Padlet. So I think you will benefit more from this presentation if you just attend and not reproduce the exercise. You will have plenty of time to do it on your own later. So, as I said, we're going to, the objective of this exercise will be to analyze the chlorophyll in the Mediterranean Sea. To do so, we're going to use 3 different products, from a model product, from a satellite observation product, and from an in situ product. So the model product that we're using is called Mediterranean Sea Biogeochemistry Analysis and Forecast. The satellite observation product has a very long name. It's the Mediterranean Sea Monthly and Daily Interpolated Surface Chlorophyll Concentration, blah, blah, blah. And finally, we have the chlorophyll time series from a mooring instrument. So this is an in situ instrument. For the model and satellite products, if you click on the links here, you will reach the Copernicus catalog, and you will find the documentation webpage of the product. On this page, you can find plenty of information about the product. You have a short description, you have the geographical coverage, the temporal coverage, the temporal resolution that are available, and most of all, you have the variables. So this is what you are usually interested in.
So we are again.
Yes.
We have some noise and we can hear you very well. I don't know if it's perhaps a mobile phone.
Is it better now?
Yeah.
Okay. Do not hesitate to interrupt me again.
Yeah.
Sorry.
Yeah. Okay. Thank you.
Okay. So so for the model and the satellite products, we have downloaded the products from the catalog. But for the in situ observation, well, the users and even I often struggle to download the products. Hopefully, we have 2 notebooks which have been developed by Paz Rutland for the previous workshop in 2020. And these notebooks are very useful and very well designed. You can find them, you have the links to these notebooks here, or in the Access in situ. So here are the 2 notebooks. In the first one, you have an extensive description of, I'm sorry, this is quite long. Okay. You have an extensive description on, no, they're here, sorry. Of the in situ products. And in the second one, you have, I'm sorry, this is quite long. And in the second, second notebook, you have, you will learn how to subset and download the product. So basically, the in situ observation, whatever region you're interested in, it's a huge data set, and you subset it by applying several filters, and then you can download the products that you're interested in. So usually we have plenty of questions on how to access these products, the in situ product. So I suggest you have a look at these notebooks. I won't have time to present you the whole notebooks now, but they are available in the training. So let's go back to our exercise for beginners. Before we start to see how to download the products, I would like to remind you that all the products that all the files that we are going to use, they have already been downloaded and they are stored in the data folder here. So you do not need to download anything in order to do these exercises for both exercises, either for the one for beginners or for advanced users. But if you want to download, if you want to study another region or another period or some other variables, you may be interested in downloading some other files, some other products. The first method I will present you is from the catalog. In my opinion, is the easiest way to access the Copernicus Marine Service. So here you have a link to the catalog. You also have a tutorial video which explains how to reach the catalog. If you go back to the here, if you take the documentation webpage from the Copernicus Marine Service, you will find that there is a data access section. Here you find all the data sets that are available. So here, if you want to study the chlorophyll with monthly resolution and 1 kilometer resolution, you click on here. You're required to enter your credentials. And then you can apply plenty of filters. So you can select the geographical area you're interested in. You can also select the time range you want and the variables. So here the product I'm showing you is only has the surface chlorophyll, but sometimes you also can choose the depth range. And then once you have selected all your criteria, you can click on download and the product will be downloaded on your computer. The second option I will be presenting you is the Motu client. This option is very useful because you can download the products directly within Python. So it's especially useful if you want to download several files to make a loop on either the variables or the dates, etc. So this can be done directly from the Jupyter Notebook. Again, you have a dedicated web page which explains how the Motu client works. But very briefly, the principle of this method is that first you reach the Motu client and the Copernicus Marine Service website. You select the product and the data set you want. Then you select the mean and max latitude, longitude, dates, and depth if the depth is available. You select your variables. You set the output directory, output file name. You have to set your username and password from the Copernicus Marine Service. And then the file will be directly downloaded in your directory, on the Jupyter Hub. So this command line may seem complicated, but if you go back to the catalog, once you have selected all your criteria, you can click on download options and then view script here. And here you can find the command line that matches that describes all the criteria you have selected. So that's it for the Motu client. The next option is the FTP method. And the example I will use for the FTP comes from a very new product, which is the nutrient profile vertical distribution. Here is the link to this product. So, well, this is a very new product. If you click here on data access, you will find that this product can only be downloaded from the FTP. So if you click here, you will retrieve the address, the link to the FTP, and this is what we're going to use in the notebook. The principle of the FTP is that so first you import the libraries, then you set your username and password. You connect to the FTP server from the Copernicus Marine Service. This link refers to the link you retrieved from the catalog just before. And so the principle of the FTP is that you reach a folder, then you list the files or directories that are in this folder. Then you go to another folder, you list what's available, etc. And you do so until you reach the netcdf file you're interested in. You have to know that in the FTP method, you will not be able to filter. You cannot apply any filter. Usually the products refer to a year, a month, or a day of data. And so here, for example, with our product, you can see that we have a directory for each year from 2002 to 2020. And if we go, for example, to the directory 2020 and we list the files in it, you can see we have one file per month. And so if we select one file, so the one from February, for example, then you can download it and the data is downloaded directly into your workspace. So our very last method to access the Copernicus Marine Service products is the OpenDAP method. So in all the previous methods, at the end of the process, we had downloaded, like physically downloaded the product. It was available either on our computer or in the Jupyter Hub. In this method, we do not download anything. We do not store anything. So it's very convenient because the files sometimes can be very, very huge, very heavy. In this method, we stream the product. We use it remotely. And all you have to do is to retrieve the address of the FTP. So again, you go to the catalog, the data access, you click on the API and you will find the link to the OpenDAP. So it's very easy. I will show you an example just after this of how to use the OpenDAP method. So this method is very convenient. Yes. So now that we know which product we're going to use and how we can download them, we are going to explore them with Python. The first thing to do when we work with Python is to import the libraries. So here is the list of the libraries we're using in this notebook. First, we're using NumPy, which is a very basic library for scientific computing in Python. Then we're using Xarray, which is used to manipulate the netcdf files within Python. We are using Matplotlib for the figures and the library Cartopy for the maps. All these libraries are very widely used. You can find the documentation webpage on the links. So here for NumPy, for example, you have the documentation webpage. You also have plenty of examples on the internet, and so you shouldn't have trouble for whatever need you have. So, well, they are very widely used. But if you do have some problem, do not hesitate. I will show you the email address at the end of this notebook for you to send us your questions. And so, yes, do not hesitate if you struggle with anything regarding the notebooks. So in this cell, we import the libraries that we need. And so now that the notebook is set, we can start to load the files. So as I said, the files are already stored in the data folder. So we have netcdf files here. And so the first thing to do is to define the path to these files. So this is what we do here. We set the path to the three products we are using. And then we are using the Xarray method open dataset. If you click on the link here, again, you will have the documentation page of this function. And here we open the product and we store them into some Python variables. In this cell, we do what I was presenting you before, the OpenDAP service. So as you can see, instead of having a path to the product, you just have the address we retrieved from the catalog. and you will see that it works just the same. As I was saying before, all the products you download from the Copernicus Marine Service, whatever method you choose, they are all netcdf files. And so netcdf files are a very basic way of storing data. They consist of coordinates, dimension, and variables. So here, for example, we take the satellite observation variable. We can see that the dimensions are time, latitude, and longitude. Sometimes you also have the depth as a dimension and the coordinate. And you can also have a look at the variables. If you click on this button here, you will access the attributes of the variable. So you have the long name, the units, the min and max values, etc. And if you click, let's take for the time, for example, on this button, show hide data, you can find all the values that are represented. So here, for example, you can see we have 5 date times, etc. Just to show you that the OpenDAP works just the same. Here we had stored the OpenDAP product in this variable, and you have the same kind of information, except that the file that we had downloaded, we had subset it because we cannot download very huge file in the catalog, but with the OpenDAP service we can. And so we can see that we have more time dates and more latitude and longitudes, and we also have all the variables available in the product. So if you want to study one specific variable, so you can see, for example, in the OpenDAP product, we have several variables. If you want to study only one of them, you can select the variable by using either dot and the name of the variable, or this way. So they work just the same. And if you do so, you can see that you now only have the variable, you only have the chlorophyll, and you no longer have the other parameters. With this method, you, however, keep the information on the coordinates, so you still have the time, latitude, and longitude. But if you want to access only the data in the shape of an array, just like you would for an NumPy, if you put the data, you will see that you only have the values. So here we have not a number, because these not a number values refer to the landmasks. We do have data in this product. Okay, now we can begin to study the Mediterranean Sea chlorophyll concentration, because now we know how netcdf files work and how Python can be used. The first thing that we will be interested in is to subset the data set. As I was showing you before, the products contain many date times usually. And if we take again the satellite product from the OpenDAP service, we have 15 date times that are all listed here. And we may want to select the product at just one date time. So this is what we are going to learn. We have several examples here, depending on the situation you're in. You can either, if you know the exact date that you want to study, so if you want to study especially the 1st of November 2021, this date is represented exactly in the product. So what you have to do is to use the xarray.cell method and then specify time equals the date you want. And if we run this cell, you will see that we no longer have a time dimension because we only have one value now, but the time is, well, the time that has been selected is the date we have specified. However, if you do not know the exact date, well, if the date you're interested in is not represented, let's say if you want to study the 5th of November, the 5th of November is not represented in the product. So you have to specify a method. So here we choose to take the nearest one, but you can also make a linear interpolation to study, well, to select this date. And so if we run this cell, you can see that it has selected, we had chosen the 5th of November and it has selected the 1st. You can also choose to select the date from an index with the index. So if we want to take the index 9 of the time, we use the iCell method. So it works just the same. And then the index 9 refers to the same date. Finally, the last example is to select a range of date. And to do so, you can use the method slice. So again, it's the .cell method, time equals slice. You put the start and end date. And if we do so from August to December, you can see that indeed the dates at the end go from August to December. So here I've shown you the examples for the dates, but these methods work for all the dimensions, so the latitude, longitude, and depth as well. So now we can start to plot our very first map. We are going to plot the sea surface chlorophyll on January 2022 from the satellite observation product. So when we want to plot figures, we have to check first the name of the variables, because sometimes the latitude is called lat, sometimes it's called latitude, etc. So this is very useful to plot the variables before making your map. So here is what we do. We select the satellite product. Here we select the chlorophyll variable. We select the time from January 2022. Before starting to see the technical details of the code, I will show you the result because it will be easier for you to understand. So here we are plotting the sea surface chlorophyll in January 2022. The color refers to the chlorophyll. The units is milligrams per cubic meters. And that's it. So first we create the figure. We add the axe and we define the projection of the map. We add the coastline. This is the black line here. We add the grid lines. We remove the labels of the latitude and longitude at the right and at the top. So here we do not have the labels, as you can see. We add the land mask and we set the extent, so the geographical extent we want for a map. So this is the min and max, longitude and latitude. To represent the chlorophyll on the map, we use the function pcolor. And then we specify the longitude, latitude, and the chlorophyll. We set the min and max values and the color map. So the min and max value go from, well, the values go from 1 to 1.2, and this is what we have here. So very quick analysis of this map, we can see that the chlorophyll in January 2022 bloomed, especially along the Italian coast in the Adriatic Sea and in coastal region, generally speaking. The blue cells refer to exercises we propose for you to manipulate the code. You can try to visualize some other parameters from some other product. You can try to zoom to change the extent here, to change the extent of the map, to zoom in a specific region. And you can change the color maps and the min and max values, etc. The next plot we are doing is the time series. So we are going to do this time series from the in situ product. So this is the mooring. This is what the mooring file looks like. So you can see that the coordinate and dimensions are not as easy as for the satellite and model products. But still, we can see that the location of the product of the instrument has remained the same. So we have only, well, the instrument has not moved. We can see that we have some, well, plenty of variables. The one we're interested in is this one. You can see that it refers to the chlorophyll, and you can have a look at the units as well. And so here is the map that we are going to plot. Again, I'm showing you first the result, and then I will show you how it works. So at the bottom on the x-axis, we have the time. Here we have the chlorophyll concentration. We have a subtitle which tells the latitude, longitude, and depth of what we are studying. And on the top right corner, we have a mini map which shows the location of the instrument. What we do is that first we select the longitude and latitude and depth in order to put it in our title. Again, we create a figure, we create an axe, we add the grid. So this is the grid. We add the title and the subtitle. This line is very useful to format the dates in the x-axis. So it appears clearly and well, you can read easily. And then we use the plot method. So in the x-axis, we have the time, and the y-axis, we have the chlorophyll concentration. Here is how we add the minimap on the top right corner. We add the axe and the projection of the map. We add the grid lines, we remove the labels on the top and on the right. And then we use the function scatter, which put the dots where the instrument is located. So on this plot, we can see, for example, that the chlorophyll concentration bloomed in November 2020. We have, well, it's strongly increased in this period. What you can do from an exercise we suggest, what you can do is you can zoom, for example, on the peak here, or you can again study another variable or well, from another product, etc. The next plot will be a vertical profile, chlorophyll profile from the model product. So here is how the model looks like. We have the dimension depth, time, latitude, and longitude, and the variable chlorophyll. What we're going to do is that we're going to select one location. So we set one longitude and one latitude, and we select two dates, January and February 2022. We select the chlorophyll, so at this location and for the two dates. So this is the result of the, so this is what the values look like. And then we can plot the profiles, the vertical profiles. So again, here is the result first. We have, well, the x-axis refers to the chlorophyll concentration with the units. The y-axis refers to the depth. We have the blue line, which refers to January, and the orange line to February. And again, we have the map, which shows the location of the profiles we're studying. So again, we create a figure, we add the labels and the titles, etc. We have this line which reverses the y-axis so that the surface appears on the top. Then we add the minimap just like we did before, and we save the figure. So what we can see is that the chlorophyll was was larger in January than in February, and that the concentration is higher at the surface than in the bottom. This is basic analysis we can make from this figure. Again, you can try to study some other date, some other region. Well, if you change the parameters here, you'll be able to change, well, to visualize some other data and maybe find some other interesting information. The X-array data sets are very easy to manipulate. You can apply any operation you want on the data set. And so, for example, if you want to calculate the difference between these two profiles, you just have to write this line, the chlorophyll from date 1 minus the chlorophyll from date 2, and you will have the result. Here is an exercise we suggest. You can reuse the script from the previous section and plot the difference on a profile. The next plot we are making is vertical slices. Again, we are using the model product. Let me show you the result. The aim of this plot is to create a line, so here in the Adriatic Sea, and to see how the chlorophyll concentration evolves along this line and along depth. So on the x-axis, we have the longitude. The y-axis refers to the depth, and the color map refers to the chlorophyll concentration. So again, how did we create this figure? We selected the min and max longitude. The latitude is, however, well, remains the same along this line. We select one date, again, January 2022. We select the model at this date. So, well, at this latitude, along the longitude we have set, and at this date. We create the figure at the labels, title, etc. Again, we reverse the y-axis. And then we use the pcolor function as well as we did before. The x refers to the longitude, the y refers to the depth, and the colors refer to the chlorophyll. Again, we set the min and max values of the color bar, and we set the color map. We add the color bar, set the label of the color bar, we add the minimap, and we save the figure. So what we can see is that in the more coastal regions, where in shallow waters, the chlorophyll is higher than in deep waters. Sorry. And that's it. So what you can do, another exercise we suggest, is for you to change, to study another line, another region, or again, another parameter. The last cell creates an animation. So we are going to use again the first map that we created. So the map of the sea surface chlorophyll, and we are going to make a loop on all the values in order to see how the chlorophyll has evolved, with the month along the year. So we create a loop with all the dates included in the satellite product, time values. And this is the same script as before, except that when we select the model, we select from the date. We do not specify one date, but we do it for all the dates. And then we save the figure. We save each figure for each date. And then this last cell will merge all the figures that we have created and save it in GIF format. And so, well, it stops working. Okay, but if you go, it has been saved in the out directory. And if you have a look at it here, you can see how the chlorophyll, the sea surface chlorophyll has evolved in 2021. So that was our last figure. So we have learned in this notebook how to access the products, how to manipulate them with Python, how to see which variables, coordinates, dimensions, etc. they contain. I'm sorry for this. And so again, if you have, we have plotted also plenty of figures. And again, if you have some questions, do not hesitate to send us a question. Here is the mail address, so servicedesk.siemens@mercatorocean.eu. And that's it for the first notebook. Maybe we can have, well, maybe I can take some questions before presenting you the second exercise for advanced users.
Yes, okay. Thank you, Ergan. It was very interesting. I hope the participants understood your explanation. For me, it was very clear, but I'm not the target of this of the notebook. So I hope you enjoyed this session. We have several questions on Slido. Let's share my screen. Perhaps we can just answer 2 or 3 questions and then continue. And again, all the questions will be collected and we will answer the question after right after the webinar. So don't be worried about your question. So how can we access the Jupyter Notebook?
From the Padlet, you have a cell which is entitled Access Jupyter Hub. And then when you are on the Jupyter Hub, you have a notebook folder or shared notebooks in which the training for the Mediterranean Sea is available. Yes, and so you will have the link of the Padlet on the chat. And the second question is the command line to copy on the folder, the Jupyter Notebook. I know on the discussion on the chat, on the Zoom chat, someone answered this question directly, giving the key, the code. But I think there is also a participant manual. Yes, exactly. And this will answer the second question. Well, this is the second question, the command line. Yeah. This is how you, well, it's written in the participant manual, sorry. Yes, so on the Padlet, you have access to a participant manual, which is a PDF file. And on the PDF file, you have all the command line to copy the folder on your home directory on the Jupyter Hub. Okay. Yes. How can I get access to the files of training in order to try them after the Zoom meeting? Yes, through the Padlet. Again, this is the same kind of question. How do you manage to add the cost lines to the plot? Is it an extension or a function? It's included in the library Cartopy. You do not have to download anything. Once you have Cartopy, you can use the command line, the line, which the Python line from my cells, and it will work. You do not have to do anything else. Okay. How can you know which are the mean and max values to select the correct range? Usually you just try and adapt. That's what I do. Once you can read the values that you want, then these are the min and max values you need. There is no single recipe to find the correct min and max values. You have to test. How can we save the plots? For example, the mooring example, including the plot with the time series and the small map on the left corner and the subtitles. I did not present this, but when you do PLT, well, for matplotlib.savefig, you put the path to the to the figure that you want and specify the .png, and the figure is saved. But all the figures that we make in the notebook are saved, so you can find the line which
command
do
line.
this.
Okay. Okay, and we will answer the other question later. There is some question about R and the sealant mask. For example, I would like to know where I can download the Mediterranean sealant mask at 4 kilometer and 1 kilometer of spatial resolution. So okay, we don't have this file directly accessible now, but if someone from the audience have this info, and I'm pretty sure that a lot of people who attend this meeting have this information, don't hesitate to share your tips and tricks and your links to find this kind of mask. Otherwise, the service desk and the user support will answer this kind of question.